In this example, we are going to prove the following identity. Cotangent of theta divided by the quantity cosecant squared of theta minus 1 is equal to tangent of theta. First thing to note is, from a previous strategy, is that we are going to focus on the most complicated side of this identity. The reason for that is because there tends to be more things we can do, or more manipulations we can do, when there are a lot of terms. So in this case, we see the left side of this identity has a few different terms here. So that means that there should be more things that we can do. From another strategy, one of the things that we're going to apply here, or note, is that the left side involves a cosecant squared of theta in the denominator. That is very important because if we ever see a trig function taken to an exponent, one of the first things we should be thinking about is a Pythagorean identity. The Pythagorean identity I'm going to apply in this case is one of the basic Pythagorean identities given in this section. We have that 1 plus cotangent squared of theta is equal to cosecant squared of theta. Now, I can use this to replace cosecant squared of theta with the phrase 1 plus cotangent squared of theta. Or, I also can note that if I were to subtract 1 on both the left and right side of this identity, I can say that cotangent squared of theta is equal to cosecant squared of theta minus 1, which is the expression that I have in my denominator of this identity. That means I now should be able to take this expression of cosecant squared of theta minus 1 and replace that with cotangent squared of theta. So that is what I'm going to do here. In my first step for this identity, I will replace the denominator with cotangent squared of theta. I will keep the right side as it is, tangent of theta. Keep in mind that we are trying to verify identities here, so I cannot multiply, divide, add, or anything else to both sides of the equation because we do not know if the equation is valid quite yet. However, I still should be able to continue to work with the left side as I see cotangent of theta divided by cotangent squared of theta. If I factor out a cotangent from both the top and the bottom of this expression, leaving me with 1 over cotangent of theta, I should be able to cancel out those two cotangents that I factored and just have 1 over cotangent of theta on the left. Thankfully, 1 over cotangent of theta is itself already an identity. We have that the reciprocal identity allows us to change 1 over cotangent of theta into tangent of theta. And this verifies this identity.